In this video we are going to go through some concepts concerning separable equations, which is the first type of equations handled in ordinary differential equations, and it is the most basic and the simplest form of the linear ordinary differential equation, which we are going to see later through some videos in more detail. These equations are called separable because the variables x and y on both sides of the equations are being separated. And the general form that we have is n of y dy over dx equals m of x. So you can notice that on one side we have the function which is of y, and on the other side is only the function of the variable x, and here is y. In that case we call them then separable. And our goal is to find the y of x and x explicit function, which will be then the solution of this differential equation. So the strategy here is to integrate both sides with respect to x. And when we do that, we obtain the integral. I will just write here again, integral n of y dy over dx, again dx, so this comes together with the integral, equals integral of m dx. Here is m of x, of course, meant. Now we want on the left side to get rid basically of this dx, and formally we can just cancel it because they are basically, that is differential, so it is a function. But another way to do it is actually just to introduce the function, the substitution v of x equals y of x, and then have dv equals the differential of y as y prime x dx, but y prime is dy over dx, and then times dx. And this fits very well because, as you can see in this box, I will highlight it here, we actually have already the expression here, and then so that will be dv, and ny will just be nv. And there we have the two different integrals on two different sides, so that solving the ordinary differential equation of this type is actually reduced to solving integral or the integration problems, which is belonging to calculus 1 or calculus 2, as you like. So when we solve that, then we are having y of x equals phi of x for some function phi as an explicit solution. So that's how the separable functions look like, and we will see now on example 1 how does that work. So the question says solve y prime equals 5y cubed x. Now you can pause the video and try on your own, go a little bit back again from the beginning of the video, see what is y prime, see what is how to make this separable equation, and we will present now the solution. Now y prime is actually dy over dx, so we can write dy over dx equals 5y cubed x. A natural way here is to divide by y cubed. Now when we divide, we have to make sure that y cubed is different from 0 or y of x is different from 0. Now y of x equals 0 is a solution. So remember here y of x is, so y is always meant as y of x. So y is not some number, y is a function. So we cannot simply divide by y, but we also have to see if that what we exclude is a solution. Now this is also a solution. Why? Because y prime is then equals 0, and 5 times 0 times x is 0, so this is satisfied always. So yx equals 0, which is a constant function, is a solution. And that we will keep for later discussion. Now we can go back. Again, let's just rewrite. And now we can divide by y cubed, both sides. That is 1 over y cubed dy dx. 5x. Okay, now we can multiply by dx, or if you want integrate, it comes to the same thing. 5x dx, and formally we put integral, so that is integral dy y cubed equals integral 5x dx. These are the basic integrals, so this is y minus 3 plus 1 minus 3 plus 1 equals 5x squared over 2, or y to the power negative 2 over negative 2 equals 5x squared over 2. We can multiply by negative 2, and that is 1 over y squared equals negative 5x squared. And of course, when we integrate, we have the variable of integration c. And this is the general solution of the ODE, so the ordinary differential equation, starting which is the separable type of separable equation. What we can do further as giving more details to this is solving the initial value problem here. And let us say that we have that y of, let's say, 1 equals 4, and we need then to find the exact solution, so exactly 1 with respect to the family of curves which is given here. So how can we do that? Well, if y of 1 equals 4, that means that when x equals 1, y equals 4. So we can substitute that here, and we will have, so 1 over 4 squared equals minus 5, 1 squared plus c. So here is 4, sorry, here is 4, equals c plus c. That means 1 over 16 equals negative 5 plus c, or 1 over 16 minus 5 equals c. Here is 16, 1 minus 80, which is minus 79 over 16 equals c. So the solution of this problem is then 1 minus 1 over y squared equals 5x squared minus 79 over 16. And that is the specific curve that we have as a solution of this problem with the initial or a boundary condition for this problem, or the initial value if you want. So this is the initial value. Okay. Let's solve one more problem. So question 2. Y prime equals x squared plus 6x minus 2 over 3y plus 1 dx, that, and y of 1 equals 7. Again, you can pause the video and try answer. So first step, we write y prime as dy over dx, and that is x squared plus 6x minus 2, 3y plus 1. This condition will come later, so to it when we find the general solution. An easy way to understand is basically a cross multiply, but don't forget the brackets. dy equals, in the brackets, minus 2 dx. Now integrate both sides. 3y plus 1 dy equals integral minus 2 dx. Now we solve separately, so this is 3y2 over 2 plus y equals x to the power 3 over t plus 6x squared over 2 minus 2x plus c. Okay, and here is an interesting thing now. So we can write 3 over 2 y squared plus y equals x to the power 3 over t plus here is 3x squared minus 2x. Okay, I will for the moment just forget this c, and you will see shortly why. Let's just multiply by 2 both sides, or by 2 over 3. So y squared plus 2 over 3 equals 2x cubed plus 2x squared minus, okay, maybe doesn't really change too much, but okay, at least with y squared we have. And then we can write as, here is y minus 2x cubed plus 2x squared minus 4 over 3x equals 0. As a very general form, this is quadratic trinomial of y of x. So that here, so we can write y of x equals, so here a is 1, b is 2 over 3, and c is this whole cubic function basically of x, and we can write so minus 2 over 3 plus minus, here it is over 2 b squared, which is 4 over 9 minus 4ac, so 4 times, so it will be plus, and then 2x cubed plus 2x squared minus 4 over 3x, and then over 2. So this is our function, and we have now to find that y over y of, we have said y of 1 equals 7. So we have found that for y equals 1, we are asking, can it be 7? And if we substitute 1 in the expression that we have for x, then we are getting minus 2 over 3 plus minus with the square, 4 over 9 plus 32 over 3. You can use calculator. So with the plus it is 2, with minus it is minus 1.3 repeating, so it's never 7. That means that there is no curve in the general solution satisfying this initial condition. Okay, if we had like y of 1 equals 2, then we would we could take one of them and say that is the one, but for y of 1 equals 7, there is no such solution. Okay, so we will see more examples in the following videos. Thank you for watching.